9-2 is where we're going to be today. So multiplying polynomials, easy thing. What property do you see there on example A? That's exactly it. That's what we're going to do pretty much all day today. It's distributive property. Distribute this 8 to both pieces. 8 times 3x would be 24x. 8 times -7, -56. And you're done. Okay? What would the degree of this be? 1. The exponent on the x is 1. That's the only one there is, so that's the degree. What would we call this? Classify it as. How many terms? 2 terms, so it's a binomial. So, and that's just some review stuff from last week. So we're going to kind of try to get some of that to help some of the folks who've been out and folks that were here that may have had a little bit of trouble with that. So that's kind of what we've done in the past. We did some of that in the fall, like August, September kind of time frame. Well, what we're doing now is we're distributing something like 6x to 5x plus 2. So it's 6x times this binomial. Okay, so when you multiply 6x times 5x, 30x squared, because x times x is x squared, and then 6x times 2 would be 12x. What would the degree of this one be? 2. The biggest exponent on each term. That's a 2, that's a 1, the biggest one is 2. So the degree of that would be 2. What would we classify that as? Binomial. Okay, so that's 9-1. That's a lot of the stuff we did there. Okay, so not too bad so far. Let's hop up here. Let's do -2x to the third, 5x squared minus 9x. Okay, -2x cubed times 5x squared minus 9x. Okay. What property is this still? It's still distributive property. That's all it is all day, is distributive property. So we're distributing -2x to the third to both of those pieces, or everything that's in parentheses. So -2x cubed times 5x squared. Be -10 for the number, and x to what power? 5th. Add the exponents. 3 plus 2 is 5. And then we're distributing -2x cubed to a -9x. Negative times negative is positive. 2 times 9 is x to the third times x. X to the fourth. What degree would that be? 5. Biggest exponent. Since there's only one variable, it's just the biggest exponent on the variable. Okay, 5. What would we classify that as? Binomial. It won't always be a binomial, but like this example. Let's say we had 5x parentheses 10x squared minus 3x plus 8. What property is that? Still distributive property. How many things are we distributing 5x to? 3. Everything that's in the parentheses after it, that's what we're distributing. So we're saying 5x times 10x squared (50x to the third), and then 5x times a -3x. Is that a positive or a negative? Negative, so a minus sign in front. And then 5x times 8. 40x. Plus or minus? Plus. What's the degree of that? 3. Degree of 3, what would be classified as? Trinomial, because it's got 3 terms. So the prefix for 3 is tri. We call it a trinomial of degree 3. What if we had a fraction out there, 2/3 x, parentheses, 12x squared minus 6x plus 9. Kind of pick some good numbers there, but is it any different? It's got the fraction, but as far as process goes, still doing the same thing. We're still distributing 2/3 x to all three terms. So 2/3 times 12. What's 2/3 of 12? And you can use a calculator. I'm not. Be 8 x to the what power? 8x cubed. 2/3 of 6. 4 x to the squared. 2/3 of 9. 6 and then an x. What's the degree? 3. What will we classify it as? Trinomial. Okay. So single distributive property, distributing a monomial to a polynomial is what we're doing. A monomial, remember, is just one term. That's like the 2/3 x is a monomial. This is a polynomial that we're multiplying it to. Not that that matters. All you've got to really know is that it's distributive property. That's all you really have to know, is we're doing distributive property a bunch today. Okay. Let's look at the next problem. It takes it to the next level of what you need to be able to do. And that's where we have a binomial, x minus 4 times something else. This is still distributive property, but it's distributive property twice, because what's in front has how many terms? 2. So we're going to have to distribute each of those terms to the parentheses after it. Okay. So we're really distributing this whole thing to both of those terms. We're going to do it one piece at a time. So if I multiply x times 3x, what's that going to be? 3x squared. And then I'm going to go ahead and distribute x times 2. Plus or minus? Plus, because it's positive, so we plus 2x. Okay, that gets us the first term distributed. Let's go ahead and distribute the second term. Negative 4 times 3x. Negative 12x. Negative 4 times positive 2. Negative 8. Okay, so first term distributed, that's written in blue. Second term distributed, thank you. Second term distributed is written in red. Okay, you want to do them in order like that. And you may see, if you look this up on the internet or something, you Google how to do this, they may say something called FOIL method. It's the exact same thing as that. I just don't call it that. It's just distributive property. FOIL method and distributive property are the same thing. So if you ever see FOIL written, like you watch a video on YouTube or Khan Academy or something like that, and they say FOIL this, they just mean distribute. That's all they mean. And I don't call it FOIL method when I'm doing it, because it doesn't work always on bigger things. Now, are there any like terms in this? Where? The plain x is in the middle. They got 2x and negative 12x. Put them together. What's positive 2 and negative 12 together? Negative 10. So we got 3x squared, a negative 10x, and then the minus 8, and we're finished that problem. So once you distribute, then you look to see, are there any like terms I can put together? And that's order of operations. You know, multiplication comes first, then addition and subtraction. So we multiplied by using distributive property, and then we did addition and subtraction with our like terms. That's what we're going to want to do here. Okay. So look at this one. X plus 3 times 6x minus 5. So again, we're going to distribute how many times? Twice, because the piece in front has two terms. So I'm saying x times both of those. X times 6x. X squared, right? And then x times -5. -5x. And then do the other one. +3 is what we're distributing. +3 times 6x. +18x. 3 times -5. -15. Any like terms in there? Yeah, those in the middle. 6x squared. What? Plus 13x minus 15. Not too bad so far, right? Let's do another one. So we had 4n, just changing letters here, -1 times 3n plus 5. What are we distributing? 4n. 4n times 3n is 12n squared. 4n times 5. 20n. And then -1 times 3n. -3n. -1 times 5. Like terms? 20n and 3n. And positive 20n minus 3n is 17n. Everything else stayed the same. Okay. Binomial times binomial. Distributive property twice. Okay. Doesn't get much harder than that. Let's look at this one. Say we had x plus 5 times 2x squared minus 3x plus 7. What's different about this one than the last three we've done? It's a binomial and a trinomial. But will the same process work? Yeah, because we're still just multiplying everybody in this one times everything in that one. So let's start with the x. How many times do I distribute the x? 3 times. So x times 2x squared. 2x cubed. X times -3x. -3x squared. X times 7. I'm going to show you a little trick that I like to use. When they get longer, sometimes it's easier to stack it up so it doesn't take up as much room, but you stack it up with the like terms, like in a column. So when I distribute the next piece, the 5 times 2x squared is, so I'm going to put it underneath the -3x squared. So that's 10x squared. And it's positive. Just remember it's positive. Okay. And then 5 times -3x, -15x, and then 5 times 7. Now, here's the beauty of that. When you stack it like that, then you just put the like terms together. Is there anything like this one? Drop it down. 2x cubed. What are these two put together? 7x squared, right? Positive 7x squared. What's positive 7 and -15x? -8x. Is there anything like the 35 up here? Nope. So just drop it down. Plus 35. And now you're done. You put the like terms together. When they get longer, stacking it up it helps, I think, keep it organized. Okay. You could stack it on the short ones too if you wanted to, but they're short enough. I don't think you really, it doesn't help you much because you're only going to overlap one term. The longer the problem, the more you're going to overlap. let's try another one of those. Let's say we had, let's do something funner, more fun. 3x squared plus 7 times negative 4x cubed plus x squared minus 5x plus 11. That's a good number. So this one is definitely pretty long. You got 2 terms here, and you got 1, 2, 3, 4 terms there. So stacking it up is going to help you a lot. So where do we start? 3x squared times every one of those. Okay, so 3x squared times negative 4x cubed. Okay, keep going. Good job. Negative 15x to the third. Squared, right? Now, you got to distribute the 7. 7 times negative 4x cubed. Okay, where's that go? Under the negative 15. So negative 28x cubed. And then keep going. 7x squared. Last one. We've stacked it up. And now all we got to do is add the columns together. So just drop the ones that don't have anything else in there. And then what's negative 15 and negative 28? Negative 43x cubed. 33 and 7. And then the others don't have anything alike, so I'll just drop them down. That should be a 5 there. I don't know why I wrote a 2. There we go. What would we classify that answer as? Just a polynomial. It's more than 3 terms. Anything more than 3 terms, we're just going to call it a polynomial. 3 terms is the highest that we give a special name. What's the degree of that? 5. Biggest exponent on x. All right, let's start putting together what we did last week with this. So let's say we had x plus 3 times 5x minus 6. I don't know what letter I'm on. K. Plus x minus 7 times 2x minus 10. So here we have a problem that has some multiplication and some addition. Which thing happens first? Distributive property, because it's what operation? Multiplying. In order of operation, multiplication happens before addition and subtraction. So we've got to multiply out both of these things before we can start adding like terms together. So let's do this first one on the left. X times 5x of x squared, x times negative 6. Yeah. Micah has caught on. And then 3 times 5x, 15x, good. And then negative 18. Okay. Then I'm going to distribute on the other one. Before I start combining any like terms, I'm going to go ahead and do that multiplication. So x times 2x, 2x squared, good. X times negative 10. Negative 10x, good. Watch your signs. And negative 7 is what we're distributing now. Negative 14x. Last term. Yeah, positive 7 because it's negative times negative. Be careful on your signs because if you miss a sign in your multiplication, it's going to mess up your addition and subtraction. Now we look for like terms. And when we were doing this last week, I told you start with the highest exponent. So we're going to start with what? The x squareds, yeah. So this one and this one go together. That'd be 7x squared. And then we got a lot of stuff that's a plain x, right? Combine all of those like terms. So we got negative 6 plus 15 is positive 9. Minus 10, negative 1. Minus 14 be negative 15. And that gets all of these guys. $70 minus 18 would be 52. 52. A big long problem simplified into this trinomial.
Would it be easier? I know it's an extra step. It's not going to make a difference in the end. But if you took your negative 6x, yes, and done that and brought it down.
You could. Absolutely. Yeah, that if that makes
less complicated.
It might be less complicated if you do that. It's going to be, like I said, it's not going to change the end result. But yeah, if you want to go ahead and put those together before you add the two separate ones together, that's fine. Yeah, you can do that. You can do that. Absolutely. All right. Do one more of those, and then we'll do an application problem. Then we'll. Let's say we had 2x plus 3 times x squared plus 5x minus 6 plus x minus 1 times x plus 1. I think this one will highlight what Miss Sandy was kind of saying there that could help. So what do we do first? Distribute left to right. So what are we distributing first? 2x times x squared, 2x cubed, plus 10 x squared negative 12x. Good. And then keep rolling. Plus 3x squared. 15x minus 18. That's the first one. Just distribute it out. And then I'm going to go ahead and distribute the second one. X times x. X squared. X times 1. Negative 1 times x. Negative x. Negative 1 times 1. Negative 1. Okay. So what Miss Sandy was saying is that, hey, what could I just put together my like terms, on the blue part and the red part first? Yeah, that you can do that. What happens over here on this red part here with those two? They cancel each other out, so we don't even have to worry about those now. And then here I have a 10x squared and a 3x squared. So that's 13x squared. And then I have a negative 12x and a positive 15x. That's 3x minus 18. And then I've still got x squared and minus 1 to put together. So this goes with this. So the 2x cubed stays the same. Becomes 14x squared. Remember, there's a 1 understood to be in front of that. So when you add them together, it's a 1. So 1x squared plus 13 is 14. And then the 3x, there's nothing else. It's an x. Negative 18 minus 1, negative 19. And you simplify. So it really, like Ms. Sandy said, it's not going to change the end result. You can add like terms at any point after you've you got to do your multiplication first. That's everybody has to do that. But as far as when you're combining like terms, if you want to do them all at once or do part of them, write that answer down and then do the rest of them, it doesn't change the final result. You can get that out of that. All right, let's get a little quick application problem for this stuff. Yeah. All right. Draw yourself a little rectangle. Doesn't have to be real big, just a rectangle. I'm going to label this side 2x plus 5 and this side x plus 6. And my instructions are to write an expression for the area of the rectangle. Absolutely. Good, Austin. Right. Good, good. So he's saying you take 2x plus 5 and x plus 6, just like the problems we started with. An example like F. And it's just distributive property. Yes, sir. That would be perimeter. We're talking about area. So, yeah, if it were perimeter, yes, you would involve multiplying those by 2 and adding. But we're dealing with area, so it's length times width. So that's the key to this, is know which formula do you use to get that. So here we distribute 2x times x. Okay, and then 2x times 6. 12x. 5x. Plus 30. And then simplify that. 2x squared plus 17x plus 30. And there would be your expression for the area of that rectangle. If you were to write, let's kind of take what Micah was talking about, because there are some problems like this, and since he brought it up, I'll just go ahead and do one. Write an expression for the perimeter. Okay. What is the formula for perimeter? Perimeter. You could add up all the sides, so you could say length plus width plus width. That's adding up all the sides. And we know that the length is what, 2x plus 5, and the width is x plus 6, and you plug that into place. Or you could do this. This is the shorter formula that you'll see probably in a lot of books. Is perimeter is 2 times the length plus 2 times the width. Get the same answer as just adding up all the sides, but a shorter problem to work. So this is what I'm going to use. Okay. So my length is 2x plus 5, so I'm going to plug that in there. My width is x plus 6. It really doesn't matter which one you call the length and width. If you have those swapped, it's fine. Now, what's going on here? Distributive property, what's going on here? Same thing. Okay, so distribute across 4x plus 10 plus, and then simplify. 4x plus 2x would be 6x plus 22. And that would be your expression for the perimeter. If you just plugged in 2x plus 5 and 2x plus 5 and then x plus 6 and x plus 6, you get the exact same answer. It's not going to change, and I don't care which way you do it. I just did it this way to incorporate some distributive property in there. And this formula is more likely the one you're going to see in a textbook instead of that one, even though they say the same things. All right, just take some practice with this stuff. Distribute, and then add your like terms together if you have any. If you don't have any like terms, then once you've done your distributive property, you're done. Okay, so just look for those. On page 565, let's go 3 through 13 and then 17 through 41. Let's do odd only, okay, on all of that set. So just the odds on that whole set is what we're doing today. Okay. sir.